The square root function is f of x is equal to the square root of x. So let's see what this graph looks like. So again, we're going to make a table of values. We're in charge of x. So I'm going to pick the same x values I've been picking. So from -3 all the way to +3. We're going to take each x value and plug it into the function. So f of x is the same thing as y. So here it's y equals the square root of x. Okay. All right. Let's start plugging in here. I am going to start with -3 here. Okay. When I do this, okay, wherever you see x, you need to replace it with -3. So if x is -3, the corresponding output is going to be y equals the square root of -3. Okay, and as soon as you see this, alarm bells should go off. You cannot take the square root of a negative number. Okay, that's a big time error. So let me write that up here. Okay, so you cannot take the square root of a negative number. Okay, so what's going to happen here, okay, is if x is -2 and if x is -1, the same issue is going to happen. Okay, so if x is -2, we're going to get y is equal to the square root of -2. If x is -1, we're going to get y is equal to the square root of -1. You cannot have a negative number under the square root. If you took any of these values, square root of -3, square root of -2, square root of -1, and punched it into your calculator, you're going to get a big time error message. Okay, you cannot have a negative number under a square root. Okay, so what does this tell us? Okay, we have to rethink our table of values. Okay, so yes, for all the other functions we've done so far, we could pick negative x values. Okay, we cannot pick negative x values for this function. Okay, can't have a negative under the square root. All right, so what happens now? Okay, I'm going to go ahead and X these out because they're not good for us. Okay, we can't pick these guys. Okay, let's think about x equals 0. Okay, is that going to be possible? Okay, well, if x is 0, okay, then that means the y value is going to be the square root of 0. And the square root of 0 is 0. Okay, you can take the square root of 0. The square root of 0 is 0. Okay, so that means if x is 0, the y value is 0. Okay, so a big shock here. This graph goes through the origin. Okay, now let's keep going. Okay, 0 worked out for us. Okay, so now if I look at x equals 1, that means the corresponding output is going to be the square root of 1. Okay, the square root of 1 is 1. Okay, so if x is 1, y is 1. All right, so that worked out. We could plug in x equals 1. Okay, now let's move on to x equals 2. Okay, if x is 2, that means the y value is going to be the square root of 2. Okay, now let's think about this. We don't know the square root of 2 off of the top of our heads. Okay, this is actually a number. Okay, it's a strange number. If you put this in the calculator, if you look at the square root of 2, it's like 1.414 ... It's some crazy decimal. Okay, so because it's some crazy decimal, this is going to be a difficult point to plot. So what I'm going to do here, it's okay to plug in x equals 2, but it's not going to give us a nice output. Okay, so what I'm going to do is ignore this point. Okay, it's doable, but I'm going to ignore it. Okay, what happens to x equals 3? Well, the same thing. Okay, y would be the square root of 3. Again, that's a crazy decimal. If you punch in the square root of 3 to your calculator, you're going to get something like 1.73 for your y value. And again, that's going to be hard to plot. We like things that fall on the grid lines. Okay, so once again, I am going to ignore this point. Okay, so what are we going to do? Because so far, we only have 2 points on our graph. We have the origin and we have 1, 1. okay, that's not enough to tell us what the graph looks like, okay? So let's think about what we're doing here, okay? We are taking the square root of something, okay? So we need to be smart about how we choose our x values. We need to choose x values that we know the square root of. We know the square root of x equals 0. We know the square root of x equals 1, okay, off of the top of our heads. It's a nice number. So going forward, okay, we can't pick negative x values. We can only pick positive x values. We've seen that already. So what besides x equals 0 and x equals 1 will give us a nice number? Well, if x is 4, okay, then I'll make another column over here, okay? If x is 4, well, then the y value is going to be the square root of 4. The square root of 4 is 2, okay? So if x is 4, the y value is 2, okay? So that x equals 4 is a nice number to plug in, okay? So if x is 4, y is 2. So the point 4, 2 is going to be on the graph, okay? All right, let's think about it, okay? Let's keep going, okay? What about x equals 5? Okay, I don't know the square root of 5 off the top of my head, okay? If x is 6, I don't know the square root of 6 off the top of my head. If x is 7, don't know the square root of 7 off of the top of my head. If x is 8, I don't know the square root of 8 off of the top of my head. But if x is 9, then the y value is going to be the square root of 9, and I know that one off the top of my head. Square root of 9 is 3. So if x is 9, the y value is 3. That's going to be another good point to plot. Okay, so if x is 9, y is 3. Okay, and then the last x value on our grid here is 10. If x is 10, the y value would be the square root of 10. Don't know that off of the top of my head, so I'm not going to bother with that point. Okay, so we've got 4 good points to plot on this graph. Okay, we've got the origin, 1, 1, 4, 2, 9, 3. Okay, and I've already plotted them as we were going along. Okay, so this is what the square root function looks like. Okay, you've got these points. Okay, we're going to connect them. It's going to look like this. The square root function starts at the origin. Okay, and then it goes through these points like this, and it goes this way forever. Okay, this is the complete graph. Okay, something you should notice, okay, there is no graph over here. Okay, and the reason for that, basically on this side to the left of the y-axis, that's where your x values are negative. Okay, remember, you can't plug in a negative x value. Okay, so that's why there is no graph to the left of the y-axis. Okay, all right, so notice that. Okay, this is the complete graph. All right, square root function is going to be very popular when we do section 3.5, when we do transformations. This is a graph that is often transformed. And when I talk about transformations, that just means we're moving the graph up, down, left, right, or reflecting it in some way. So you absolutely want to know the square root function. You want to know the 4 key points on this graph, and I'll go ahead and label them so you can make sure you see this. Okay, you need to know when you hear square root function, bells need to go off in your head. You need to write down 0, 0, 1, 1, 4, 2, and 9, 3 to make the graph. Okay, these are the 4 key points you want to remember. Okay, so now that we figured out the graph, let's talk domain and range. Okay, domain. Okay, what are you allowed to plug in for x? Well, we know negative x values are doozies. Okay, we can't have a negative x value. We can't plug a negative number into the square root function. You can't have a negative underneath the square root. So x can't be negative. Okay, as far as domain, you can't plug in negative numbers. Okay, 0 worked and positive numbers worked. Okay, so that's kind of the idea here from the table. You can plug in x equals 0 or anything positive. Okay, if you look at the graph and you look at the x values that this graph covers, what I'm going to do here, let's see, I'm going to do some highlighting, okay? I'm going to highlight the x values that this graph covers, okay? The graph starts at the origin, so x equals 0, and then after that, you always have a graph, okay? So basically, the x values that the graph covers are x equals 0 and then any positive x value, okay? We can also see this from the formula, okay? Remember, the function is just f of x is equal to the square root of x. When we talked domain from the formula in section 3.1, we talked about how to handle square root functions. If you want to find the domain of a square root function, remember what the rule is, and I'll write it up here, okay? If you want the domain of a square root function, the rule was to take the quantity under the square root and set it greater than or equal to 0 and solve, okay? So if we applied that logic here, okay, I'm going to take the quantity under the square root, which is x, and I'm going to set it greater than or equal to 0 and solve, okay? Well, it's already solved, okay? This is telling us that the domain here, you can only plug in x values that are 0 or bigger than 0, okay? So, you know, if you look at your number line, remember I had you solve the inequality and then you had to turn it into a number line, okay? So what would be our domain here? Okay, the key point here is 0. We can plug in 0 itself or anything bigger, okay? So if you wrote this in interval notation, this is going to be, we're going to start at 0. We're going to go off to positive infinity. And since we can actually plug in 0, we want to include that point. Okay, so for this particular graph, the domain is going to be from 0 to infinity. Okay, this reflects what we saw in the table. Okay, we can plug in 0 or any positive number. It reflects what we see in the graph. Okay, you just cannot plug in a negative number for x. Okay, what about the range? Okay, well, range is y values, so we need to look at the lowest point and then go to the highest point and write down the y value. Okay. Again, the lowest point on this curve is going to be the origin, okay? So the origin has a y value of 0. We want to include that point. We want to include 0 in the range because 0, 0, that's a closed circle, okay? The high point of this graph, okay, this side of the function, it keeps going up, 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 up forever, okay? Notice that it is a very slow rising curve, okay? Eventually, it will go up to like y equals infinity, okay? But it's going to take a long, long time to get there, okay? It is rising, but just slowly, okay? So the highest point on the graph will eventually be, you know, positive infinity. So we're going to say our highest y value is going to be positive infinity, okay? So the domain and the range of this graph are the same, okay? Both are 0 included all the way to positive infinity, okay? All right, let's take a look at our last basic function, okay, and that's going to be the cubed root function, okay? First of all, do not confuse this with x cubed. They are two different functions, okay? They are going to have similar shapes, but slightly different, okay? So make sure going into this, you realize that the cubed root of x is not the same thing as x cubed. All right, so here we go. This is a little different, okay? We've got a radical, okay? We just did the square root of x, but now we've got the cubed root of x, okay? So let's think about the difference here. How does the cubed root of x differ from the square root of x, okay? We have seen the cubed root of x before. We examined this function in our very first lesson in section 2.1 when we were looking at symmetry, okay? If you remember, this is the snake graph, okay? And we'll see that again in case you forgot, okay? But let's first talk about what differentiates a square root from a cubed root, okay? When we talked about this back in section 2.1, we said one of the big differences between a cubed root and a square root is that you can have a negative number under a cubed root. Okay, you can't have a negative number under a square root. So that is a humongous difference here. Okay, you can have a negative number under a cubed root. Okay, and I'm actually going to write that down here. You can take the cube root of a negative number. Okay, big time difference from square root. Okay, all right, so we're going to make a table of values. Okay, we get to pick the x values, and then we're going to plug into our formula here. Okay, so the y value, f of x, is the same thing as y, so the function is going to be y equals the cubed root of x. Okay, we have to be smart about what we pick for the x values, just like we were smart when we picked the x values for the square root function. Okay, when we did the square root function, we had to pick x values that we knew the square root of. Okay, now we're going to pick x values that we know the cubed root of. Okay, so I'm going to start. I know the cubed root of 0. Okay, so if x is 0, that means the y value is going to be the cubed root of 0, which is just 0. Okay, and remember why the cubed root of 0 is 0. That is because if you take 0 and multiply it by itself 3 times, you get 0. Okay, so shocking again, I know this graph goes through the origin. All right, what else do we know the cubed root of? Well, 1. Okay, so if x is 1, the y value is going to be the cubed root of 1. Okay, the cubed root of 1 is 1. Because if you take 1 and multiply it by itself 3 times, you get 1. Okay, so the cube root of 1 is 1. So this graph is going to go through 1, 1. Okay, all right. So let's keep thinking. What else can I take the cube root of? And I know that answer off of the top of my head. Okay, well, the next thing is going to be x equals 8. Okay, so if x is 8, the y value is going to be the cubed root of 8. What is the cubed root of 8? It is 2. Because if you take 2 and multiply it by itself 3 times, 2 times 2 is 4 times 2 is 8, you get 8. Okay, so if x is 8, the y value is 2. Okay, all right. Now, the thing is, okay, so obviously we picked x equals 0, and then we picked x equals 1 and x equals 8. The negatives of these also work because you can have a negative under the cubed root. Okay, so if x is negative 1 or if x is negative 8, these guys should work as well. Okay, so let me start with negative 1. Okay, if x is negative 1, then y is going to be the cubed root of negative 1. The cubed root of negative 1 is negative 1. Because if you take negative 1 and you multiply it by itself 3 times, negative 1 times negative 1 is positive 1 times negative 1 is negative 1, you get negative 1. So the point negative 1 will be on the graph. And then if we look at negative 8, okay, that's our x value. We plug it in. The y value is going to be the cubed root of negative 8. Okay, the cubed root of negative 8 is negative 2. Because if you take negative 2 and multiply it by itself 3 times, okay, you get negative 2 times negative 2 is positive 4 times negative 2 is negative 8. Okay, so if x is negative 8, y is negative 2. Okay, all right, so these are some points on the graph. Okay, so we're just going to plot these. Okay, so this graph for the cubed root of x, it goes through negative 8, negative 2. Negative 1, negative 1, the origin, 1, 1, and 8, 2. Okay, so you get an S shape. If I connect the dots, whoops, let me try again. You get an S shape like this. This is that snake graph. Okay, it looks like this. I'll even write this here. This is the snake graph. Again, if you go back and look at x cubed on the previous page, okay, this is an S shape as well, okay, but it's more vertical, okay, as opposed to x cubed. The graph is an S shape, but it's more horizontal, okay, so x cubed and cubed root of x are not the same graph. They are very, very similar. You need to recognize the difference, okay? All right, so let's talk domain and range here. Domain, think about the table of values, okay? We can plug in 0 for x, we can plug in positive numbers for x, we can plug in negative numbers for x, okay? So nothing got us in trouble. If you think of the formula, when we talked in 3.1 about domain from the formula, remember, if you're dealing with a cubed root function, the domain is all real numbers, okay? Because you can have that negative underneath the radical sign, okay? If you look at the graph, okay, if you follow my cursor, the graph's going to keep going this way forever, okay? So the leftmost x value is going to be negative infinity, okay? If you go to the right, okay, the graph keeps going this way, okay? So the rightmost x value is going to be positive infinity, okay? So based on all these observations, the domain here is going to be all real numbers, okay? Then if we look at the range, okay, we need to do low point and high point, okay? Again, if we go to the left this way, okay, it is a slow decline, but that graph is going down, 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 just very slowly. So eventually it will make its way down to negative infinity, okay? So that'll be your low y point. And then on this side, it's going up, up, up. It is rising just very slowly. So eventually this y value will climb up to positive infinity, okay? So the range is all real numbers here, okay? Both domain and range, okay? So these were the 6 basic functions you need to know inside and out. You need to know what their graphs look like. You need to be able to state their domains and range, okay? It is very important for when we get to transformations, okay? These are some of the basic functions you will be transforming, meaning moving up, down, left, right, doing reflections, stretching, compressing, that type of stuff, okay? So you have to be able to graph the function quickly, and you have to write down specific points on each graph. So make sure you learn these 6 graphs.